Mm-hmm.
uh, and I think yeah, I think I can share the screen as well, right? Can
Yeah, yeah,
everybody see
yeah.
that?
Yes, yes, yes.
Okay.
Hello, Uttam.
Good afternoon, sir.
Good afternoon, Uttam.
Good to have you in the audience.
Yeah, thank you.
Online meeting is there from 3 to 4. I just came and set my computer.
Hello, everyone. Can I request all of you to mute yourselves? We'll begin in a couple of minutes. Uttam, are we good to start? I think it's 3-2, so people keep joining. We will start it off, right?
I'm good to start whenever you want me to,
Okay.
Gautami.
Okay, sure, sure. Thanks. So yeah, hi everyone. Thank you so much for joining today's webinar. A warm welcome and good afternoon to each one of you. I am Gautami, working as a senior manager at IESA, and I handle events, startup Mitra program, and government affairs for Karnataka. So let me take a quick 2 minutes of yours for a brief introduction about IESA. By the way, this webinar. Also, before I could start, I request each one of you to mute yourselves and take up any questions at the end, right? Because a lot of noise is coming in between. I don't want a webinar to get disturbed. Can I please request every one of you to mute yourselves? Thank you. So today's webinar is hosted by IESA, that's a Startup Mitra program, along with Elixir Private Limited. So, as you all aware, the topic is about the e-waste recycling in the context of sustainability and EPR. So before getting into the topic, or before me introducing about the speaker, let me talk about IESA. What IESA? I think most of you must be aware about IESA. As the name says that it's an India Electronics and Semiconductor Association. We are an industry body association, work with the industry and the government, to work for the betterment of the ESDM ecosystem. So under IESA, we run programs and the initiators like Startup Mitra and the Campus Connect program, just to cater for the betterment of the ESDM ecosystem. So and then today we have a speaker from Elixir. So I welcome Dr. Uttam Doraswamy, currently a founder and CEO of Elixir Private Limited. Thank you so much, Dr. Uttam, for taking out this time today, to present something over this topic. I feel that this topic has become so important these days that, we as a responsible citizens, that recycling of the e-waste or any waste, it is important and, for our sustainability. So let me introduce about Dr. Uttam. He has a PhD in chemical engineering from Imperial College London. He has worked in energy, chemicals and materials and R&D and technology department in the US and India.
Understanding of product conceptualization, design.
Chandra Mohan, can you please mute yourself? Yeah. So Uttam is now the founder and CEO of Elixir Private Limited, an e-waste management and recycling firm, transforming the waste into valuable materials, recirculating the material back into the market. So I think, with the 45 minutes of the presentation, I'm sure that you will be with a very insightful knowledge about the e-waste recycling in the context of sustainability. Over to you, Uttam. Please take up the questions in the last 15 minutes. We will open for the discussion. And I don't want to hear any noise in between, so I'm making a request for you all to mute yourselves when Uttam is talking. Thank you so much. Over to you, Uttam.
Thank you, Gautami. Thank you for the introduction. Welcome everyone for the next 45 minutes while we look at e-waste recycling, particularly in the context of sustainability and the latest EPR, or extended product responsibility rules that have been introduced by the government. So I've structured this presentation to introduce us to e-waste. Most of us are familiar with it, but I think it behooves us to spend maybe a few slides to understand exactly what we're talking about when we're talking about e-waste. Then moving on to what we mean by sustainability and why the two are interlinked. And I think we'll spend a few slides on looking at the link between e-waste and sustainability and how directly impactful e-waste recycling is in sustainability. And then towards the back end of the presentation, I'm going to focus a little bit on the legislative framework that we are in currently and what the current e-waste rules are in 2022, including looking at examples of what the impact of the rules would be perhaps on some of you as bulk consumers or producers or manufacturers of e-waste, representing the companies that you work in. So in light of the time that we have, I'm going to go fairly quickly. If you have any questions, please hold them to the end, and I will try to come back and address them as we go along. So I always start my presentations with this word cloud. And I like to spend a few minutes here because it's very illustrative on why we're here, why we're in this webinar at the moment. And the word crowd I constructed by taking out news articles between 2017 and now, and looking at the amount of times particular words were repeated. So what the word cloud does is it tries to bring into focus what is in the text that people are talking about when it comes to e-waste. Since my focus search term was e-waste, obviously e-waste takes center stage and it's the word that's used most often. But what I find the most illustrative is to look around that word e-waste and then start to see what people are saying about e-waste. And you can see that in the first circle around the primary center, you can see people are talking about rules, collection, recycling, environment, tons, electronic. But I've always found that the next level and the level beyond that are probably the most interesting, in the sense that for this cluster of words, what are the words around these that make these connected to our daily lives? And here you can start to see manufacturers, equipment, government, pollution, problem, unorganized, health. So e-waste encompasses a lot of things, and its management is going to impact our daily lives in many ways. And I think the sustainable management of e-waste is going to be one of the most important things that we can collectively do as a society, between the government and us and industry, because of both the values that are embedded inside electronic waste, but also because of the risk that we've distributed inside electronic items. So what does the government define as e-waste? And this has changed a little bit. So now it's basically electrical or electronic equipment, whole or in part, discarded as waste, as well as rejects from manufacturing, refurbishment, or repair. So you can think of this as anything that used to work on electricity or enabled something else to work on electricity when you no longer need it. And this is a complex definition, and I skipped the solar photovoltaic on purpose because this has recently been included in 2022. And what the government is saying is solar panels also, we need to fit them somewhere. So we'll put them into the e-waste legislation, but we don't have any recycling capacity for solar panels. And so currently the guidance is that solar panels are just going to be stored until we know what to do with them. So I deliberately excluded them in the main definition, but this now is a very broad catchment. It's almost everything that touches electricity at some point in its lifetime, and need not be a definition on its functionality. So the part could well be functioning, but it's a part of a unit that's no longer needed and therefore is discarded, or a subunit of it may still be functional, but it's still discarded. So functionality doesn't really have a bearing. It's more to do with whether the part was of origin that was electronic and ever had any touch point with electricity and is now no longer needed. So when you break this down, what are we really talking about? So from a commercial perspective, this breaks down into largely small IT equipment, stuff that you would see in an office everywhere, whether this is computers, phones, printers, EPABX systems, that sort. Or it breaks down into the large white goods that you see in our houses, televisions, air conditioners, and then more complex things like screens, lamps, lights. But when the rules originally started, I think 16 had maybe 15 or 19 different items defined. Now we've crossed 100, and the government is somewhere between 100 and 120 items, if I'm not wrong. And it's still a very small list, because when you look at the definition of e-waste in the words, this includes everything, from toys to hair dryers to waffle irons to things you would see in your kitchen. Electricity usage has become so ubiquitous in human society now that almost everything we do touches at some point an electric connection, and therefore almost all of those items, when they reach end of life, will qualify as e-waste. So the spectrum of material that qualifies as e-waste is massive. And I think the government is always going to be playing catch up in trying to make sure that everything that needs to be defined under the rules are defined in the schedules that they have. So today the schedules are much better. They include all sorts of things from both production machinery, whether you take a sewing machine from a garment industry, or you take an air handling unit from a software building. These are all now caught, whether you take medical electronics, some of those have been caught, toys have been brought in. So I think this is a race between the government and the people who are defining the rules in terms of CPCB and MOEF to make sure that the schedule is representative of all the equipment that there is out there. So why is this important? It's important because e-waste is one of the fastest growing waste streams in the world. So there is a particular section in the United Nations that has both ITU, UNU, and UNITAR that spend every 3-4 years, they produce a report specific to e-waste. And over the years, it's become very clear that e-waste is one of the fastest growing waste streams in the world, even faster than plastic or solid waste, because our addiction to our devices is very strong, and our assimilation of electronic devices into society is extremely strong. So if you look at the per capita numbers for mature economies with higher spending power, they are averaging 16, between 15 and 20 kgs per individual of electronic waste. In India, that's a much smaller number because we have a very large denominator over which everything gets divided. And I think in India, that number is about 2 kg per individual. But the numbers here clearly show you this is about 62 billion kgs. If you put this into trucks, this would be enough dump trucks to encircle the equator. So it's a massive volume of electronics that are discarded as e-waste. And only 22% of that is formally recycled. And the rate at which it's growing, that you're looking at about 80 to 100 billion kg of e-waste being produced over the next decade. And the value embedded in that, because of the metals and other valuable commodities that we use in electronics, is almost a $40 billion industry. So it's critical that we look at this from the point of view of resource. It's critical that we look at it from the point of view of management of risk. And unfortunately for us, not just in India, globally, this is an issue. And most of the e-waste is managed informally. So in India itself, the informal economy manages more than 80% of the e-waste by most surveys. And globally, that's true as well. Only 22% is being managed formally. So critical that we are able to address this challenge and move the recycling of e-waste out of the informal sector and into a formal sector. So if you look at India, India is fifth largest producer of e-waste. We're a very large country, so everything we do has a large footprint. But per capita, we are still very good. Only 2 kg per individual. Only 25% of the global average. But the issue is that the access to electronics is increasing, and because of the digital interface increasing through digitalization of almost everything that we do in the country, it's becoming critical that people have access to digital devices and electronics in order to take part in the economy. So we can expect that India will see this number grow. A few years ago, the global average was about 7 kg of e-waste generated per individual. So it's safe to say that the number in India will go up at least 3 to 4x over the next few years. And even if it stops at the global average, this is going to be a massive waste stream. So what exactly goes into these electronics and what happens at the end of life? So as I said, when you're talking about e-waste, you could be talking about a transformer attached to a power distribution unit. You could be talking about a child's toy. You could be talking about a hairdryer. So there's no one size fits all, but in general, e-waste is, e-waste is made up mostly of iron and steel, plastic, copper and its alloys, aluminium, and then you've got printed circuit boards that provide the logic functionality, and batteries that are often integrated for backup or standalone power. And many times you have some sort of glass or thermoset plastic casing. So when you break down electronics, you will get a combination of these materials most of the time in different concentrations. And typically you will have, in terms of weight, iron will be the most dominant contributor. By volume, maybe sometimes plastic would be the most dominant contributor, but because of its lower density, iron will usually dominate most weight reporting of e-waste. So I'm going to switch track now and say, okay, now that we know what e-waste is, where does it touch sustainability? And so for sustainability, I hear this term used a lot, but very often it's not very clear in people's minds what exactly it is. So we all understand that sustainability is a better way, and we should be more sustainable, but what does it really mean? So I like to think of sustainability from a mathematical perspective. So if you have conflicting requirements, and let's broadly define those requirements as environmental, which is represented by the planet, people, which is represented by our health or our well-being, and then of course commercial requirements, which is represented by profit. So you have sustainability being the optimum point that secures an even balance between these three functions. So typically in the past, when you looked at projects, whether you're looking at manufacturing projects or whether you're looking at new investments to make, uh, the main requirement that one optimized for, and I've done this as well when I was in R&D in the past, and we looked at projects from an economic requirement. So what is the internal rate of return, what is the payback period, and rarely were the social requirements or environmental requirements integrated so heavily into the project analysis stage. And of course now you started getting labor laws or environmental regulations, and those drive you to include those functions into your analysis. But what you find is that if you really optimize these, what you find at the very center would be the sustainable point.
Sorry, Uttam.
No
Can I
problem.
request everybody to mute yourselves because we have muted how much ever we could, but please, because otherwise it will become difficult to hear from the speaker, right? Thanks.
I think they've muted. Thank you. I was curious about what happened with that import duty, but now I guess we'll never know. But so that leads us to what the UN has defined, and these are widely known. I'm sure most of you have seen these before. So in order to drive down to this sustainability in society, the UN has basically said there's 17 sustainable goals that will help us move our current model into something that's more sustainable. And I'm not going to go into each of these goals, but e-waste has a touch point, a very clear touch point with a few of these goals. So when it comes to goal 3, good health and well-being, or when it comes to 6, clean water and sanitation, e-waste has a direct bearing. So many toxic elements are going into the electronics that we make today in order to drive the functionality that we want. And at the end of life, if these are not dealt with adequately, those toxic elements are either entering the water streams, or they're entering the sea, or they're getting leached out from the ground, and that's affecting both the water situation and our health. If waste is not managed properly, then goal 11 of having sustainable cities and communities will not make any progress. And at the heart of many of our relationships with electronics is goal 12, responsible consumption and production. So if we do not recover enough from our waste streams, then our mining from the earth and our taking of primary raw materials will not be responsible. And so electronic waste touches these things very closely. And I'll spend a few slides so that you can understand what the direct impact of recycling will be on these goals. Tied closely to this is the language we often see around a circular economy. And maybe some of you have seen this, maybe some of you know this at depth, maybe some of you have never seen this. So I'll spend a few minutes here. Circular economy basically is a concept that says that we should try to take back into raw material whatever we've taken out from primary resource and then used over its lifetime. And so if you see, if you take an example here, you start with raw material, you have a design, you manufacture a product. And let's take a bicycle, for example. You've got rubber, you've got iron, you've got maybe some steels, very simple materials. You distribute the bicycle, somebody uses it, maybe it breaks down, somebody extends its life, you change a few parts. At the end of its life, it's collected, and then if it's recycled, then some of those primary metals go back into raw material. And only very little bit, perhaps let's say the grease on the chain or a torn piece of rubber from the tires, that goes into a waste stream that's no longer going to come back for use. So if you look at this graphic, the tighter you pinch the point between residual waste and raw material, the more circular your economy is going to be, and therefore more efficient and therefore more sustainable. And I think this concept is going to drive a lot of new thinking, new businesses, and also force existing businesses to restructure the way they work. Because this circular economy is now a function, now at a very strong focus of government, both in India and abroad. The G20, had an entire summit around the circular economy. And so designing our design, production, distribution, consumption, and recycling around circularity is going to be very significant in the coming decade. So when I say what's embedded in e-waste, let's look at it in a different way. When we make these products and they reach end of life, if we discard these products, roughly this is what we're talking about in terms of metals. You have about 20 million tons of iron that's going into e-waste, 3 million tons of aluminium, 1.8 million tons of copper, and right down to precious metals. Gold and silver are used a lot in e-waste. Gold is used a lot in electronics as both a protection for copper, as well as an oxidative protection for copper, but as well as for parts that are repeatedly subject to physical use because of its softness. So silver and gold are also largely in e-waste, and the cost of mining these from the ground is immense. So I'm going to spend a few slides looking at what is the impact of recycling something that comes out of an electronic item, or for that matter, any item, as opposed to manufacturing that item from the ground. So aluminium is a very good example. And you spend massive amounts, it's 4,700 terajoules. And I think this is for 100,000 tons of aluminium, which is associated with 383 kilotons of CO2. If that aluminium is used and then recovered from a recycling process, this could be a heat sink on a chip, this could be an cast aluminium casing that's being used protectively. When you recover that aluminium now just goes as scrap to a remelter, and the amount of energy you need to come back to pure aluminium is only 7.6%. And therefore, the CO2 impact of using that aluminium again is less than 10% of the impact of making that aluminium. And this is very interesting because whenever we're making metals out of their ores, we're having to separate them from their oxidative state. So in the case of aluminium, we're talking about alumina. So you're going from Al2O3 to aluminium. The amount of energy you need to reduce the oxidative stage is immense, whether this is aluminium, whether this is copper. And what you're doing is actually no different from a photosynthetic process. You're reducing the oxidative state by photosynthesis to something that can produce energy, to wood. So you're using energy, but you're making a product that is now lower in oxidative state. So this is very important because for every kg of aluminum or copper or iron, or for that matter, plastic you recover, there's a very direct CO2 impact because you're not making it from the ground. So the story remains the same with copper. Most of the copper ores are sulfides, and you have to roast them, you have to smelt them, you then produce sulfur dioxide, sulfuric acid, and if you get that from scrap, now you're just having to refine it. It may not be meet your purity standards, but you're no longer separating it from its ore. And this doesn't even take into account the fact that this needs to be mined from the ground or transported. All those are adding into the CO2 number. So impact of recycling is very, very direct. And every kg that you can get recycled has a very direct CO2 impact. Same with iron. It's about a ton, of CO2 abated for every ton of iron recycled. So if we look at the scenario in India, then where does it stand? So we're at about 2 million tons generated. The data is very difficult to come by. So even though there are reports and we can say UNITA said this or it's in the last report, the truth is the flows are very difficult for anyone to really put a finger on, because once a product is used by a consumer, and whether that consumer is a corporate consumer, a manufacturer, people lose track of it, and there is no mechanism to collect that data and to understand exactly what these flows are. So these are all somewhat estimates, but it's safe to say that somewhere between a $2 and $10 billion industry is going to emerge from waste management, just around the metals. And when you add the potential for refurbishment, or when you add the potential for plastics and other associated materials, you're looking at easily a $10 billion industry that's going to be driven by recycling. Most of it today has no formal outlet. So there are recyclers such as myself, whom the recyclers have been entering the market since 2011, but majority of the material is recycled informally. What does that mean? It means that at the end of its life, this material, just like anything else, like in our houses, this goes through a kabadiwala network. It's then collected, it's then separated, and specialists informal outlets exist in, for example, Selampur or Moradabad, where copper is extracted by burning wire or by burning printed circuit boards, and gold is leached out informally in very small shops. But this has devastating consequences both on the health of the participant workers, but also on the environment, because most of the waste management of these industries involves just dumping the waste into the closest water bodies. And most of the research has shown that these water bodies are polluted with toxic metals many hundreds of times above their permissible limit. And that brings us to the risk. So it's goes hand in hand, right? So we make these electronics and we put in valuable materials. But in order to drive functionality, we also put in things that are nasty. So the simplest examples are lead. We have a lot of lead, especially in legacy electronics, because it was a part of solder. So you had a 60-40 tin lead solder. So it's plenty of lead in those. We have many plated stainless parts as connectors, as casings. Many of those are rich in chromium 6. Mercury is present in many telecommunication applications. There are still mercury switches that are used, and then you have more complicated things, cadmium, or you have PVC in wires. And then when these are burnt, you could have things like dioxins and fluorines that come out from the burning of plastics, which are carcinogens. There are particular capacitors which used to use polychlorinated biphenyls. These are now being regulated, but these are extremely nasty, cause nerve damage. So why does the informal sector dominate? So cost of recycling is high. Setting up a formal recycling unit, even at a very small scale, and we are a very small recycler. We have capacity for about uh, 2 tons a day, and I think setting up that kind of unit, especially putting in the pollution control equipment, putting in the equipment you need to manage these materials safely, tends to be expensive. And unlike most other manufacturing industries, you can't order the raw material here. Somebody has to discard it for the raw material to become available. So there's a significant supply risk in the sense that you can be in production mode, but you can't get e-waste because you don't know where it is, or it goes into the informal sector because the pricing that they pay is higher. So typically, I'm going to spend a few slides to say, if you're going to do metal recovery, you're going to have to need to shred equipment. You're going to need separators. If you're getting into precious metal recovery, you're going to have to leach things. So you would have to have acid treatment capability. You'd be able to treat those fumes. And if you're going to do smelting or melting, then obviously, you'd need appropriate scrubbing equipment and disposal of the fumes via chimneys. So these infrastructural costs burden recyclers and often make the viability a little bit difficult. In the West, what typically has happened so far is that very large copper smelters, such as, for example, Boliden or Umicore, which are doing huge amounts of copper, would use the electronic waste like PCBs as part of their copper feedstock. And since they were massive and had a lot of pollution control equipment for the copper process anyway, they were able to handle the e-waste. But in India, we don't have an active big copper smelter anymore, and the finesse and technical expertise has not been there in dealing with e-waste. So this is still an emerging industry here. What does it really mean when you recycle it? So typically, if you start from the picture panel on the left, what you're trying to do is separate the electronics as best as you can by manual dismantling. This remains the most effective way of consolidating different fractions and making sure that your raw material is somewhat homogeneous, because by nature the electronics that come to us will be extremely heterogeneous. They will have batteries, they will have wires, they will have printed circuit boards, and unless you can create a more homogeneous feed stream, very difficult to recycle. Once you have the homogeneous feed stream, then you start to use unit operations, either you're cutting and sleeving, or you're shredding, or you're melting, and producing now raw material essentially. So we produce, for instance, copper of 99.5 to 99.9% purity, and that goes back to the industry, either to people who are making components or repurifying it and using that copper downstream. A byproduct will often be plastic, and so we will clean that plastic, and that plastic will also go back to industry. And so often you'll find this plastic forming insulation on wires or maybe doormats. So what happens is that you start with a heterogeneous waste stream, but you're bringing it back at least to a raw material that's acceptable to the industry for reuse. So we'll spend a couple of slides looking at, if we do both, we do refurbishment as well as recycling. In case an item still has residual life, and this is typically restricted to IT, desktops, laptops, servers, monitors, TVs. If that life can be extended either by repair or by buying and procuring parts and recertifying, quality testing. So what happens is these get an extension of life, and then these electronics are then used by somebody else for a little bit longer. And I will touch upon this refurbishment when we discuss the rules as well. But this is also significantly impactful because the production of these electronics is associated with a significant amount of CO2. So I think it's about 300 odd kgs, 330 kgs of CO2 is associated with the production of one laptop, and large amounts of water as well. We've not captured the water here, but large amounts of water and energy go into making electronics. And so when you can extend their life in a single project, this is a single customer, you can see this is about somewhere between 650 laptops, let's say 800 assets, 750 to 800 assets have about a 300 ton CO2 impact by refurbishment. Similarly, if you're doing, for instance, a facility clearance, you're pulling out wires and furniture. All of these are made up again of similar materials, PVC, copper. The furniture is usually iron and aluminum. Um, your paneling. So other than the inert material, even just a flow clearance project at a typical IT company, which you would think doesn't have much to do with production or CO2, would still have 100-ton CO2e impact. If you can track this becomes something that the companies can then leverage in their reporting for sustainability. So often we are doing things as part of our daily operations, but we're not very clear about the impact of those things. But when you're doing something around recycling, you can be sure that if it's executed properly and the data is well managed, there's always an impact that can be tracked. One slide that pulls us back to something a little bit complex. I've spent a lot of time talking to you about iron, aluminium, copper, to some degree gold and silver, because these are the legacy materials that we've introduced into our economies. And most of our economic drivers of materials were centered around these metals. But that's changing very quickly. As we enter the new age, when it comes to renewable energy, when it comes to EVs and the new age of motility, we're moving beyond our traditional metal base to something completely different. Even our electronics are moving to more and more complex materials, which now are available less and less. So, at least you had plenty of aluminum, to a large degree copper, well distributed. Now you're coming to an age where the materials of choice, whether it's cobalt, whether it's neodymium, dysprosium, all these are required in the new economies, but are very hard to get. So you enter this band of materials called critical materials. And critical materials are defined as those that have a very high importance when it comes to their economic impact, but they have a very high supply risk. So if you look at this chart on the left, you can see that, you know, certain things are extremely critical, dots highlighted in red. So if you take europium, europium's used in, I think, nuclear rods as control rods. Neodymium is now probably the most common use is for EV motors, but also for motors for wind turbines. So these materials are going to become critical because the demand for them is going to soar, but their availability is a problem. In most batteries, at least generation, one generation prior to the one they're using now in lithium batteries, cobalt was the active ingredient used in the cathode. And I think cobalt was available in very few places. I think, for instance, DRC was one of the large sources of cobalt, and those mines were politically unstable. They were being run essentially by warlords. So, in a scenario where demand is going to skyrocket, but supply risk is very high, it's critical that we're not wasting these materials by letting them enter landfill or by recycling them at very low efficiencies. So now I'm going to spend the next few slides on particularities around the e-waste legislation. So, where were we and where are we now, and how far have we come? So pre-1990, no rule or legislation, even though electronics were being widely used, no legislation. Originally, it was brought in the early 2000s under the hazardous waste management rules, which really mirrored the Basel Convention. So we borrowed most of the hazardous management rules from the Basel Convention. In 2008, they issued it separately, but no rule was really made. The first rule came out in 2011. And these were the e-waste rules of 2011. Some concepts were introduced and some, little bit of law was put around it, but it was very weak. In 2016, for the first time, they brought up the concept of EPR. They started looking at how are recycling facilities, what are the guidelines for recyclers, dismantlers, guidelines for the stakeholders. This was amended multiple times in 2018, but the major loophole was that the EPR didn't have any teeth, and no one was really managing the certificate generation process. And so what was happening was you had EPR, but since it was not being controlled, you had a lot of paper trading. You had the same material, looping around in the market without really being recycled. And so when it came to 2022 legislation, the government is making a very strong push to not just digitize most of these things, but they're placing themselves at the center of the enforcement process. So as of today, many of you may be aware, CPCB is running the portal that is basically the arbiter of recycling in this country. You need to be on their portal, you need to report on their portal, you need to work on their portal, and the certificates are basically rubber stamped essentially by the government. So if they are not happy with the data flows through that, then there can't be an EPR structure. So this is interesting because for the first time now, the oversight is very direct, and this could be something that really changes the game in how e-waste is recycled in this country. So coming on to EPR, or extended producer responsibility, this spun out from research uh, at Lund University by Thomas Lindquist, and this is in the 90s. And it was driven mainly by one particular problem. So at the end of life, for whatever it may be, it was not necessarily electronics. Let's take, for instance, a biscuit packet. At the end of life, when you consume the biscuit and the package was left, the cost of dealing with this waste stream was largely being pushed on to um, the governments, and this was happening through for instance, in our case, it would be in Bangalore, BBMP. So they were being burdened with a collection cost, with disposal cost, if it was landfill or whatever it may be. And they were starting to complain that this is not feasible because for the amount of revenue that they were getting from taxes, they were not able to manage the stream of waste that was coming. So EPR was designed to make sure that the producer doesn't relinquish his responsibility after the product is sold. So now what happens is the producer becomes responsible for the entire life cycle of the product. The implementation of this is through rules, administrative rules, and both economic and informative instruments. So now you have to teach people where to give this stuff back. You have to incentivize them. At the same time, you have to have enough legislation to make sure that the money flows in the correct direction that enables this to happen. So if you look at today's rules, the primary stakeholders are manufacturers, producers, refurbishers, and recyclers. There's a touch point for bulk consumers and dismantlers, and I'll talk to that. But before that, which I should have said, the rules don't cover batteries, they don't cover plastics, they don't cover radioactive waste, and they've excluded consumers and micro enterprises. So they're focusing on basically those who will generate larger amounts of waste. There are 3 amendments till 2024, and for the first time, they have very clear penal provisions. They have provisions as per the act in terms of exactly how much financial penalty they can levy, and they also reiterate the ROHS directives, and I'll get to that, and very clear definitions of the scope and catchment of EPR and the execution of EPR. So if you look at the upstream stakeholders, these are the people who are producing the waste. You've got manufacturers, bulk consumers, and producers. And this is a very large catchment. And producers are not just those who are branding and selling. It could be importers, it could be those who are assembling. You could be selling only online. You could be white labeling for someone. But if you're producing these electronics and uh, they're coming out in the market in some form associated with you, then you will fall under the catchment of a producer. Bulk consumers are those that are producing or using at least 1,000 units of anything in Schedule 1 in the preceding year. Manufacturers, obviously anyone who's making electronics of this nature. Downstream, you've got dismantlers, and this has been in the last amendment, this has been loosened. In the past, I originally started my business with a dismantling license, and this was a regulated space. Now, dismantlers, basically anyone who follows the CPCB rules is allowed to be a dismantler. And then you've got 2 others, refurbisher, someone who extends the life of a product, and recycler, someone who takes the product and recovers every possible value and ensures that the items that you can't do recovery with are safely disposed. So in 2016, they had an ROHS, which is a reduction of hazardous substances. For many of you in semiconductor, you'll be very familiar with this. So they are trying to make sure that lead, mercury, cadmium, hexavalent chromium, polybrominated biphenyls are less than 0.1 weight% in the homogeneous part. So it doesn't necessarily mean the entire object. If there's a casing, all that homogeneous casing, you can't cross the limit. And with cadmium, the limit is even less. I think now there are labs that give a ROHS certification. It's a very difficult process. And I think at one point only CMET Hyderabad was doing this, but it's spread. More people are doing this now. So this is to drive toxicity out of the electronic waste. There are some slides on targets. I'm in the interest of time, so we have time for questions. I'm not going to go through these. I will leave these for those of you who want to see. It's fairly straightforward. The portal teaches you exactly how to do this, but I will spend time on this one. I will mention two things. So the way that a target is calculated is it's calculated based on historical sales. So given a lifetime for a product, which the government is defining, let's say for a TV, it's 9 years, then the target for a given financial year will be the sale 9 years ago. So for 2013-14, that would be 2022-23. So the targets come from a combination of the sale value of a given year and the life of the product. And there are certain schedules. If your company is very new, then there are different rules. You can say none of my products have reached end of life, in which case they have a 15% of the sales figure for a preceding year. There's also rules around refurbishment. If you refurbish a product, you can offset your liability by the extension of life. So for instance, if you refurbish 100 tons of computers, then that comes out of your EPR liability for the next 5 years. And even when it comes back after 5 years, only 75% of it comes back in order to incentivize people to refurbish. So simply put, we can go over these formula very quickly. The EPR target for a multi-product company would just be the EPR target for each product times the number of products. And the EPR target is nothing but the factor, which is it 60%, 70%, 80%, and this is going between 60 to 80% between 2023-24 and 2027-28. And the target itself is nothing but the sales you had in the year considering the life. So for a current year minus life, the sales of that year by mass would be the mass target. I'm going to skip that. All of the implementation is happening on a digital portal. The portal is run by the Central Pollution Control Board. It's at eprewastecpcb.in. All stakeholders have to register and get authorization via the portal. And then the CPCB has produced guidelines on what are the expected metal recoveries from a variety of commonly used and defined electronic waste items. And so recyclers will use that plus their input material to generate a credit, and producers will then have to purchase that credit from recyclers via the portal. Right. So in conclusion, e-waste is one of the fastest growing waste streams, and our relationship with electronics means that this is not likely to change over the near term. And so making sure that we address it sustainably will have deep impacts on circularity. When it comes to the semiconductor industry, achieving circularity is intrinsically tied to the emergence of a formal recycling industry. So we will need to foster adequate capacity in recycling, because the materials that are used in the semiconductor industry are largely going to be the materials that come out of the same products at the end of life. And so it makes perfect economic sense to ensure that we are getting those from the materials that are end of life. When it comes to the law, this is evolving rapidly. I got into this business in 2017, and I've already seen 3 versions of these rules. And every time they're getting more stringent, every time they're getting more complex. And so you have to stay in touch with this to make sure that you are aware of the legislation and that you're preparing plans to ensure that you're compliant with it. Human and technical capital in the recycling industry are the largest headwinds. We need more people to get into this industry with the right intent, with the right capacity, so that the industry can come out of the informal nature in which it operates today into a more formal industry. At the heart of it, waste management, e-waste in particular, but waste in general, whether it's metal or whatever else, needs to migrate from the periphery of the P&L. What we often see in business when we go out in the market is that companies, especially upper management, is very, very, very focused on the front end of the business. Their customer focus is always on the front end of the business. But when it comes down to the rejects from manufacturing, the scrap, this tends to be pushed out. A lot of it is at the periphery of the P&L. It's not a high impact item. And this needs to change. So the C-suite needs to look at this as something that's going to be very important. Even if it's not directly revenue important or profit important, it's going to be very important to drive circularity, which is going to become critical for almost all businesses. So that leaves us, I think, some time for questions. And I'm happy to take some questions for how much ever time Gautami gives us. And if there's an order for
Sure.
those questions.
Gautam, we have some questions in the chat box. Will you be able to take it up or should I read it for you?
I think I should be able to take it up.
The first question was from Shankar. Why the manufacturer themselves take care of the waste and government can give incentives for it? Why it's not made possible so far? What's the reason?
So I think there are 2 reasons. So when you look at the complexity involved with waste management, it's no less than the complexity involved with the front end manufacturing. And it's a completely different business. So let's take an example for a cell phone manufacturer. Let's say Apple. They spend a lot of their time, energy in designing and making an iPhone. But they have very little to do with the distribution, the sale, often with the repair and refurbishment, which is out with different vendors, and then with the collection and recycling. And this is a completely different business. So the manufacturing is completely different from the metal recovery. So that's asking a business to stretch too far. So that's like saying you should make a TV, at the same time you should get into the copper business. That's a very large stretch. So what the government is trying to do is saying, hey, take responsibility to ensure that it is recycled, but you can take it in your P&L. Don't try and do it yourself, because do it yourself would be too much. Can we find the certification
I hope
for
that
this
answers the
webinar?
question. Yeah.
So I think,
No,
can we
actually, we don't provide any certifications because it's just a 1 hour webinar and, we are not providing any certifications.
So that's that. Thank you, Gautami.
Yeah.
Can you name the Indian companies based on their capabilities to manage waste types? So the easier way to think about this is there are different legislations around waste: battery waste management, e-waste management, hazardous waste management, biomedical waste management. And each of these have different consents and often different companies. There are very few companies that have consents in all this space. So depending on what you're trying to dispose, the CPCB or the State Pollution Control Board usually lists the authorized companies on their website. So for instance, if you go to the KSPCB website, you'll find all the list of authorized people for biomedical waste, for e-waste, and their capacities and whether their licenses are valid or not. So that's the easiest starting point you have to identify different companies. Okay. What will be the fate of critical metals given that most technology in India are still in the nascent stages? It's a good question. I think um, we are very far away from getting to the point where we can handle our critical materials to the point that they re-enter manufacturing. I think our manufacturing tends to rely on import for components and rely on import for many, many things. And so the loop is not closed. So today with copper or with iron, we're able to close the loop relatively well. But if I produced tomorrow neodymium, I don't think I'd be able to sell it. You know, the market for it is not there, the use case is not there, the component is made outside this country. So this is going to take some time, and this is going to be a journey for producers as well as recyclers. As people start making things more in India, as Make in India takes off and becomes more mature, then there'll be an opportunity for these more complex raw materials to be integrated into the manufacturing stream. But this is going to take some time. How much tonnage per year recycler has to recycle in order to make profitable? Do you have a commodities market to sell the recycled materials? Okay, this is a good question. So I think, you know, we have recycled. We originally started with a consent of about 360, 1 ton per day, 360 metric tons per year, and we've been profitable on years where we've done even 40 tons, and we've struggled to break profitability even after crossing 100 tons. Even today, we've not reliably broken the 100-ton barrier, which means that our inflow is much less than our capacity. And this is true for most recyclers. The reason this is a little bit complicated is that profitability is a combination of refurbishment and recycling. So if you do even 1 ton of computers, that can have a big impact on your profitability and your revenue. Whereas if you do 1 ton of iron, you know, that's maybe 32,000 rupees in revenue with maybe, you know, 3 to 4% profitability. So profitability in e-waste is a very complex metric, and it's driven by what mix of high value and low value materials you're doing. And because this is a waste stream and you can't order it, you never know. Every year is a challenge. You know, some years you get good material, some years you don't. So I'm afraid there's no single tonnage that I can give you. But the answer to this would be you probably have to do at least 50, 100 tons of a mixture of materials to even get close to breaking even. Do you have experience handling rare earth materials? Um, we've looked at a few processes that recover rare earth materials, specifically neodymium. We're not doing it on a commercial scale, not even on a pilot scale. So this is all nascent chemistry that we're looking at. And the issue is really around receiving raw materials. And as I said before, making sure we have an outlet for those raw materials. So I think rare earths is going to take a little bit of time, but the CPCB is already talking about making sure that the EPR framework is extended beyond. Today, the EPR framework covers only iron, aluminium, copper, and gold. It doesn't even cover silver. So I think the EPR framework will have to grow. It'll have to include silver, plastics. It'll also have to include rare earths. And at that point, maybe we can see some small traction in rare earths. Are you recycling processing solar PV panels? So solar PV panels are not being recycled as far as I'm aware, and they're an exemption in the rules. So the rules are now saying that solar PV panels just need to be stored safely until there's a recycling option. And I think they've given a 10-year window. Maybe it's till 2032, 33. I can't remember the exact year. There are recycling options available, but panels are extremely difficult because of the backing sheet. So a solar cell by itself is not a very complex thing to recycle. But when you stick the cell to the EVA backing sheet, the combination of the adhesive and the PVF, polyvinyl fluoride, I think, backing sheet means that to recycle that material is very difficult and has no outlet. There are companies now in the West. I think one of my old colleagues is running a solar recycling company in America. I think it's called Solar Cycle, that are starting to do this, but the economics is largely driven by people paying for the recycling. So until we get to a stage where producers are willing to pay for the recycling process, I think it's very difficult. But what they're doing is they're grinding the material, recovering the metals, principally silver, copper, aluminium, anything else that they can recover. And then the ground material, which is inert, is being either briquetted or disposed. So I think that's the main process. I think Veolia also is entering this space, the French recycling company. So there's some work happening by Veolia in France as well. Thank you. Vikas, thanks for those words. Please advise how to make business case for new enterprise from e-waste. So I think business cases are going to come from two things. You're going to have to find your niche and specialization. Either you're going to be, when we talk about e-waste management, it's a massive what do you say, sliding scale of things that happen. There are going to be people who work on collection and making sure that they access clients. I think there's going to be a distribution business particular to e-waste. And then there's going to be a business on recycling and refurbishing. So today, all recyclers do everything. I have trucks, I go pick up material, I search for clients, I refurbish, I recycle. But that's because the industry is very new and one person does everything. As the industry formalizes, I think what you're going to see is that people will find their niche. There are going to be people, marketplaces for generation of customers for them to come and put their e-waste. And then there are going to be distribution companies that handle e-waste. They can handle inspections, they can handle lifting. And then there are going to be customers who, recyclers focused on copper, recyclers focused on gold, recyclers focused on critical materials. And I'm hoping that that's how the industry will evolve. But potentially we're looking at another decade before we get there. You can't do it in a small colony. Recycling is intrinsically a dangerous process. It's also you're going to need energy, you're going to need chemicals. So it's classified as red in the pollution control terms. So you will need to be located in an industrial area that has permission for red processing. Recycling process in a street, so that's illegal. People do it. I'm not saying there are no illegal recyclers, but what they're doing is they're dealing with hazardous chemicals or illegal furnaces in very small units, away from the eyes of the law. But this comes with a cost. As I said before, the cost is usually borne by the people who work in those places, and it's a terrible process. Remember, gold originally was processed using mercury. The original process for separation of gold is with mercury, and there's still people who follow that. But in order to do this correctly, you would need to have a facility that's located in an industrial area. Yes, it should be made a lucrative industry. I agree. But I think for that, many things need to change. Public awareness needs to change. Legislation needs to improve, and the legislation should work. In India, we legislate very easily, but for the legislation to trickle down to results sometimes doesn't happen quickly. And so I think the legislation needs to trickle down for it to work, and then we'll see an industry emerge. No talk of carbon credits yet, Abhay, but the government is getting involved in this green credit program. And I see that in the rules that there's a little flexibility written in, saying that at some point we may be able to link this to a credit incentive scheme, exactly like you're saying. So maybe we are going to see an emergence of a tie-in between recycling and carbon credits coming through what the government is calling their green credit scheme. So today that green credit scheme is dominated by tree planting and it's dominated by afforestation. But I think there's a scope for that ambit to increase beyond that, in which case I think you will see that there will be a framework for carbon credits in e-waste. How to strike a balance between the usage or utility of these materials and its sustainability issues in the near future? I think, Dr. Chandana, that's a great question, because I think the right answer is not going to come from a better recycling. It's not going to come from more effective recycling. All those will help. But I think the heart of that question is going to be addressed by our relationship with the materials we use. I think over a couple of generations, we've lost our relationship with the materials. A, they've become much more complex. B, our relationship with them is a lot more transient. So if I look at the bicycle my grandfather had, it went down to my uncle, I rode that bicycle. We kept materials for a very long time, and at the end of life, we treated them much better than we treat the materials we have today. So for things to become more sustainable, I think it's going to be a balance between doing more, recycling more, being more efficient, but also examining our relationship with these things, and whether we really need some things that we need, and whether whether we can teach the producers not to sell us as much as they sell us. So today, we dance to the tune of the market. We dance to the tune of the way the producers sell electronics to us. Perhaps that will need to change for a really sustainable point to be reached. Who will do public outreach programs? So as per the rules, producers have to do them. So that's part of the rules. The rules say that producers are responsible, but recyclers also are. So I find I do a lot of public outreach programs. We think that helps in getting public awareness to a better level. So you'll find probably public outreach happening in some way through producers or recyclers. Yes, we can do training sessions. So if you can reach out to us separately, we can definitely do a training session for you, Praveen. What are the areas, technologies that you would invest research time and energy with the highest impact in the goal for circular economy or in recycling? So I think it's also a great question. Somebody came up with the solar. I think solar recycling is going to be something that is begging for investment. So that's definitely something that I would look at. Critical materials, as I discussed, it's a nascent area. Nobody's doing it. So definitely an opportunity there. I think in recycling, those are the two that I would pick up. In the circular economy, I think it's an open playing field. So there's so many opportunities that are coming out both from energy and materials in the circular economy that you can't go wrong. Even if you look at distribution, even if you look at financing alone, how do you finance circular economy projects? How do you finance waste management and recycling projects, whether it's in conjunction with government or whether it's standalone? The financing alone may be an area that people should be investing, and I think venture capitalists and others are already coming into this space. Amit says governance in the company is important to make priority on sustainability, especially on scrap. Right. Senior management prioritize money rather than sustainable disposal. I agree, but I think they don't necessarily have to be separate. I don't think it's true that you have to be either sustainable or get revenue. I think when the industry comes to a point, you should be able to get fair revenues and still be sustainable. Today, the problem with scrap is that there's not enough oversight. If someone was buying a raw material, then the visibility on the purchasing process, how it's happening, how is the contract written, is with a high degree of senior management visibility. Whereas in scrap, that doesn't happen. So we see many models where people are saying, scrap can be dealt with in the same manner. We understand it's a commodity, copper price is going up and down, but you can tie this to the index. You can say you can buy for the next 3 months at 80% of the index value. So I think there are models which can be fair and sustainable. But for that, I think the visibility needs to be higher. In electronics, another concern is excess component inventories that are held up by all. Yeah, this is a huge concern. Excess inventory, which is being disposed as scrap, is absolutely a problem. And this goes back to the circular economy at the design and plan stage. So what I would say here is my comment independently is that often many of these purchasing projects are driven by sales. They're driven by people in marketing, they're driven by people in sales who don't really think of materials in the same way. So unless stocking and unless design and production is also taking into effect these things and is not driven only by marketing, you are going to have excess material. And I think that's something that is easily addressed. Rahul,
So, with the interest of time with them, can we just take it offline because we are
sure.
at 10
I think
minutes?
I think there's a
Yeah.
lot more questions, but
Yeah. So with a lot
apologies.
more questions asked from the audience, that itself we can, understand that how interesting the presentation of yours was. So I know by today's presentation, like we would, at least we got a fair idea, like what actually is e-waste management for the people who doesn't know, and then how to do it, what are the effects that if we don't do it. So it's very well captured in the presentation, and I'm very sure that all our audience would have had an insightful discussion with a lot more questions only we can actually say. So thank you so much, Uttam, with your expertise.
No problem. Happy
We
to help.
will take it offline, if at all, if they have any questions or if any training programs or something. I see messages from your team as well. I think they have already given out the email ID and then the contact details. I think, the audience can reach out to the Elixian team for that. So
Right.
once again, IESA thanks the entire team of Elixian and especially you for your insightful presentation, and to all the audience who took out the time to register and then to attend the webinar.
Yes.
Thank you
Thank
so
you all
much.
for
We
your
will,
attention.
yeah. We'll come up with one more webinar in the next month under the same program. So just keep waiting. Thank you so much. Thank you
Thank
all.
you.
Thank you.
Thank you.